Hello everyone and welcome to Oriana Unlock. I am Oriana and on this channel we're going to be diving deep in order to unlock new knowledge about topics that truly matter. And today we're going to be unlocking what it takes to build a second home for humanity. And no, this is not a sci-fi movie, it's actually real life. Our guest for today is an aerospace engineer and she's also a professor at the Technical University of Munich of Human Spaceflight Technology. But her work is far more interesting than that. When we go to space or when we go to the moon or Mars, we simply can't take our atmosphere or our grocery stores with us. That is why our guest's research focuses on human life support systems and how we could use biology like microalgae, for example, to create oxygen and food that humans might need on the long term in space. She has not only theorized this because she has actually sent a photobioreactor experiment to the International Space Station to test how these tiny green powerhouses could work and could react under microgravity. She has also been a key mind behind the NUA project, a breathtaking concept of a Martian city of 1 million people built onto the cliffs of Mars. So from engineering how we could breathe up there to designing a whole Martian society, our guest for today is paving the way to future outside of Earth. So please join me in welcoming our incredible guest, Dr. Gisela Detrell. Dr. Detrell, thank you so much for joining me today. It is truly a privilege to have you here in Oriana Unlock to unlock this whole new world, literally, of how we could be living outside of Earth. Thank you.
Thank you for the invitation. It's my pleasure to be here today.
Okay, so I want to start by asking, when you were 16, which is my age, I know that you have been fascinated by space for a long time. So when you were my age, was human life support systems already on your radar? Or were you just interested in space in general and in rockets?
I'm afraid I'll disappoint you. I was not interested in space when I was 16. I was interested in engineering, though. I was interested in solving things, learning how things work, how they can be repaired. So my focus was very much on engineering, not necessarily space. With space, I found my way over the years. I decided to study aerospace engineering, as I could have studied any other engineering degree. Because all of them look very interesting to me. But while I was studying, I discovered how space is actually very cool. So I started more because of airplanes, but then I discovered a new world about satellites, about rockets, about astronauts. So on the course of my studies, I actually got very passionate about space.
Most people think of aerospace as purely engines and aerodynamics, but you actually focus on the human inside of the machine. Why is keeping people alive the most exciting part of engineering for you?
I like the fact that we are able to live in places that are not made for us. Yeah, living in a space station in the middle of space, or at some point going back to the lunar surface or living on Mars, is something that we have to fight for. We cannot just go there; it's not ready for us. So we need to find solutions for that. So that brings a really cool challenge to solve, to figure it out how we can do that. And the fact of thinking that humans, we can expand beyond Earth, it's also a very inspiring factor. I don't say we all have to leave Earth and go everywhere else, but the fact that we can, that we're able to go and explore and go farther beyond the moon and to other places, I found that really amazing.
You did send an experiment to the International Space Station involving microalgae and all of that and biology. So can you unlock for us what the experiment was about? And what did you feel like the moment that you saw that your experiments was being launched into orbit?
So our experiment mixes a lot of biology and engineering. I am an aerospace engineer, so I focused more on the engineering side of the experiment, but it was a very interdisciplinary project with also biologists being involved. So it was really a team effort of people from different disciplines. And the experiment itself was a photobioreactor, so the box where the algae can grow. And that box needs to have a certain geometry. We need to provide light. We need to control the temperature. We need to control the gas exchange. So the algae will take the CO2 around the atmosphere they have, and they will produce oxygen. And we have to deal with this CO2 and this oxygen. So there's a lot of engineering that needs to be done because this needs to work perfectly and in microgravity. So it comes with a lot of challenges to solve when designing the experiment. It was a really cool project. It was several years of work because it's the work you do before you get the experiment, that you prove that you can do that, and then building the experiment itself. It was amazing to know that we were building things with our hands that would be up there. I would have loved to go myself up there, but at least our experiment went. And it was a really interesting process also to learn how it works, because designing an experiment for space sounds very cool, and it is, but it also implies a lot of bureaucracy and safety steps that you have to follow. So there's also part of the work that it's not that much fun as the rest of the experiment, but it was really an amazing experience. And I went to the US to see the rocket launch. I saw the rocket going up with our experiment inside. And of course, that proud of the entire team that worked on that, knowing that it was going up. It was really an amazing feeling. I highly recommend everyone that can get involved, because it is a really exhausting, but it's a very good experience.
Is it true that algae could be the superhero of human life on Mars? Like, for example, could a teen like me in a future Mars colony be really breathing that oxygen created by the green slime and then eating that same green slime for dinner? And if you've tasted it, how does it taste?
I find it interesting you call it superhero. I've never put algae and superheroes in a sentence together. Yes and no. So yes, algae could be a solution for the future, for humans living on Mars, or even farther away at some point, to get their oxygen and their food. But we also should consider that we cannot only eat algae. As humans, we need to have a balanced diet with certain elements that are included in our food. And only eating algae would bring us a lot of protein, which is good. We need protein, but we also need other things. We need carbohydrates, we need fats. And one of the superheroes that we will have probably, that will be complemented with other plants or other biology living organisms. It will not be the only solution that we will use, but one of them, I hope, yes. And if they taste good or not, it's really a personal thing. Most of the people don't like the taste of algae. It's very salty. I don't like it very much, to be honest. But since we're not eating only algae, we can mix it with other things. So the taste shouldn't be the problem.
Now I want to get into Nuba. It's not just a base, but it's actually a city for 1 million people built onto the cliffs of Mars. So I wanted to ask you, why a cliff? Is it just for the view, or is there actually an engineering reason behind it?
It's an engineering reason behind it, and the reason is we are not on top of the cliff where we would have the nice views. That's the part of the station is up there for certain resources, but where the humans live is actually inside the cliff. We would build tunnels inside, and the main reason for that is radiation protection. Here on Earth, we are very lucky that our Earth has something called magnetosphere that protects us from space radiation. It doesn't let the space radiation get into us, so the Earth is safe for us to survive, to live. But if we leave our Earth and we go into space, the radiation that we get is much higher, and a lot of radiation for a short period of time might still be okay, but for long periods of time, it can become deadly for humans. So we need to protect us a lot from this radiation, and especially when we consider living permanently on Mars. That's a long time. So we really need a big protection. And that's why we decided to do tunnels on a cliff. I don't think we're the only ones that have proposed that. Most of the people, though, propose to either go under the surface, so to build tunnels under the surface, or to cover the bases with material. In our case, because the goal was to build a huge city, a really big one, we thought that a cliff offered a more compact possibility, that we could have the city in a more compact volume than if we would go on tunnels on a very big surface. So that was the reasoning behind why in a cliff.
Dr. Detrell, I also want to ask you a very simple question, but one that I'm very interested in. Why Mars? Why not any other planet on our solar system?
So Mars is one of the objectives we have for human spaceflight. The other one is the Moon. Those are the more realistic scenarios that we can think about for the next decades, if not even longer, for humans to visit. The other planets in our solar system have a very dense atmosphere or are gas planets. They are farther away anyhow, so they are more difficult to reach and more difficult to live in. The Moon and Mars are the closest objectives that we have, and also the ones that have conditions that do not allow us to live there, but that we can bring our habitats easily to, or not easily, but that we can get our houses built in one way or another. So those are the objectives that you will probably read or hear about everywhere for human spaceflight, which we might achieve hopefully to the moon in a couple of days. We'll have a mission at least around the moon, so we'll be hearing a lot about the moon the next years, and hopefully Mars as well. Might take a little longer, but yeah, those are the two likely scenarios.
The aerospace world is always changing, as technology is, as science is, but it hasn't always been easy for women to take the lead. Have you ever felt like you've had to engineer your way around glass ceilings? And what is your current take on the role of women on space tech and their importance?
We are still a few percentage in the sector, unfortunately, but it's increasing. I'm happy to see that it's increasing, and I keep having more and more colleagues, also at higher positions. So it's changing on the good direction, maybe not at the right speed, but it's changing. In my personal case, I have to say I was very lucky. I grew up in a family where my father was a professor, my mother was a teacher, and I had technology things to play with when I was a child. So for me, it was very clear. As I mentioned, I wanted to be an engineer when I was your age. So that came for me as a normal thing. And I always lived that as a normal thing. I've mostly been surrounded by men during the university time, during my first jobs at the university, currently as well. So unfortunately, that's the case. We are a small percentage, but I try to act normally about that and fight my way and just prove that I'm able to do what I do, and that has worked out so far. I think I've been very lucky to have a very nice environment around me work-wise. All my work colleagues, I never had the feeling they treat me differently for being a woman. But of course, these things happen, unfortunately, still, and we have to fight for that. And I think the best way to fight for it is showing who we are, that we are capable, and there are plenty of women doing this job, and that we can do it at least as good, if not better, than the men. So just showing those examples, I think, should be the way of changing. Will take time, but I think we'll make it.
Is there any myth about being a woman in aerospace that you'd love to debunk for a young generation of girls like me who dream of developing professionally in this field?
No, I don't think I have any particular thing to say in that regard. Again, dare to, don't doubt yourself. That's what we sometimes women do more than men, that we doubt ourselves. Can I do that or not? We shouldn't. Because men usually don't. We tend to be more careful in that sense, and of course, it's important that everyone knows their own limitation, women and men. But and don't let others tell you that you're not good enough to do a certain thing if you know you are. So fight for yourself.
Dr. Detrell, in your seminars and in your talks, you always say that we should start living more like Martians here on Earth. So what is the first step towards a more Martian life, and how does building a city on Mars help us save our planet right now?
That's a very good point, because we sometimes are criticized. Why do you want to build all these things in space? Don't we have enough problems here on Earth, right? And yes, we can learn to live here on Earth better if we think how we would like to live on Mars. Because on Mars, we have to be very aware of the resources that we have, and that they are limited, and that we have to use them very wisely and recycle and not waste anything. And that's something we could learn a little bit from here on Earth. Sometimes we see how we have problems here on Earth with we waste food, we waste water, we don't make a proper use of water sometimes, and then we have problems of scarce water in certain areas. So there's a lot of this thinking on how to live with less resources, or optimizing the use of the resources that we have, that we could definitely use here on Earth. We don't need to live here with the same restrictions as on Mars, because we do have a breathable atmosphere around us, but we could learn some things and make a wiser use of our resources when we think how we would live on Mars. So that's the link for me, doing research on Mars and making a better Earth here. Yeah.
Everything you have mentioned has been incredibly interesting, truly. I cannot help but wonder, what projects are you unlocking for yourself at this moment? Are more smart-related projects in the works right now?
So what we are working now at the moment with my group, It goes in the same direction. We're still working with microalgae and looking for, at some point, hopefully, to send algae to the moon. We don't have a project right now specifically for that, but we're looking towards getting funding for the moon. So imagining a lunar base at some point, permanent, hopefully in the next years. And with that, we would like to be able to do the research necessary first, so that algae can be part of this lunar base. I've recently moved to a new university. It's been 2 years. It doesn't sound too recent, but building a new professorship, a new lab, everything takes time. So we are still in a development phase, but we're still working with microalgae. We're also working on the conceptual design of human spaceflight missions, like we did with NUBA. We're focusing a lot on the lunar surface at the moment, more than in Mars, but similar direction. And we also are working with physical and virtual reality simulators to evaluate human performance, to be able to evaluate when a human is maybe isolated for 6 months on its way to Mars, and he has to develop a maneuver. How often should this astronaut train? Should he train daily? Is it better to train daily and maybe get a little bit tired of repeating the same maneuver over time? Or is it enough to do it a couple of times a week? Does it make a difference that this person is isolated compared to a person having a normal social life here on Earth where you can go out and things like that? So we're also looking on investigating those type of parameters.
Lastly, Dr. Detrell, are there any insights, words of advice, or simply some motivation you would like to share to our audience today?
I would like to share a thought because wanting to be part of space does not necessarily mean being an aerospace engineer. Of course, I encourage everyone that wants to be an engineer, like I did as a child, to do so. But if you're really good at other topics, if you want to work rather on the law sector or on the food production sector, we need all these disciplines also for the space. So if you have a passion for space and you're not that into engineering, we need all the other disciplines as well. So in space, pretty much any discipline you can think about could fit. So for all those having a passion for space, just follow your passion with whatever job you would like to do in the future, because there's a lot of overcrossing from medicine, from material science, from absolutely most of the disciplines, considering also space law, human factors. Everyone can fit in one way or another in the space sector. So if that's the case, go for it.
Well, thank you, Dr. Detrell, so much for joining us today, for your words, for sharing your passion with us. It has truly been a privilege to talk with you, for your time, of course. Thank you so much, because I think everyone who is watching this interview and myself, I leave this interview with a renewed passion for engineering, and obviously having discovered the importance of aerospace engineering in a different brand. Thank you so much for showing us that space travel and space research is just as important as it is with the engines and with the rockets than it is with the human inside of the rocket. Thank you so much for also being such an inspiring role model for us girls who dream of developing in aerospace engineering and in STEM in general. It is truly inspiring to see how your work has been so influential in a stereotypically male-dominated field, and how you have managed to turn something out of a sci-fi movie into a blueprint for future generations. I, for one, will be looking at your work and your research in the future very closely, especially every time I see a green pond and I see that algae in the pond. I will remember that maybe that algae is the reason someone might be breathing in Mars or in space in the future. So thank you so much for being here, for being such an inspiring role model, and for having the time to share this with us. And thank you all for watching. If you enjoyed this interview as much as I did, if you learned and unlocked new knowledge as much as I did, please do not forget to subscribe to the channel, to hit that like button, to ring the notification bell, and to follow me on all of my social media accounts at Oriana Unlock on Instagram and on TikTok, so that you never miss out on a new opportunity to unlock new knowledge. Thank you, Dr. Detrell, for being with us today, and thank you all for watching. Keep learning, keep questioning, and keep unlocking your full potential. I will see you next time. Bye!